carrying forward from this, going ahead to trigonometric identities, just a recap of what we had done earlier in the last class that we met in the chapter of Introduction to Trigonometry. Trigonometry is basically a relationship between the sides and angles of a right angle triangle. The ratios that we learned were, in a right angle triangle ABC, if it is right angled at B, we have sine of A, cosine of A, tangent, cosecant, secant, and cotangent. So as we had done, I had already told you a small verse on how to memorize this. Some people have curly brown hair, turn permanently black or blue. That's how we were working in the class. Then we were looking into the values of certain standard angles. Now 0, 30, 45, 60 and 90 are known as standard angles. So I taught you how to find the values of all the angles with respect to sine, cos, tan, cosec, sec and cot. So I had told you how to do it. So I told you to memorize the first one, and the other one is just the reverse of it. And tan, you know, is nothing but sine upon cos. We also did complementary angles. In complementary angles, we saw that sine of 90 minus A is cos A, cos 90 minus A is sine A, tan 90 minus A is cot A, cot 90 minus A is tan A, secant 90 minus A is cosecant A, and cosecant 90 minus A is secant A. This all we had done till the last class we met. Now moving ahead to it, now we are moving on to trigonometric identities, in which we have three very important ones, which is cos square A plus sine square A is 1, 1 plus this plus tan square A is secant square A, 1 plus cosecant square, cot square A is cosec square A. Now we are going to work on this part. So let's take it further. So the identities that we will be using at the moment will be, as I said, cos square A plus sine square A is equal to 1. I would want everybody to write this down in blocks at the top of the page. Hope you are all using a new page. You have put down the date today and write these three identities in bold there, please. And then I'm going to move ahead with this. So now moving ahead from this. Now this is what is given in your textbook. Hope you have got your textbooks in hand, children. So now what are identities? What is an identity? Actually, it is nothing but an equation. What is an equation? Balancing the left hand side and the right hand side. So similar to that, we have trigonometric identities in which we have the left hand side and the right hand side. So for all values of theta, the left hand side and the right hand side would be the same. So that is what is said. It is called an identity when it is true for all values of the variables involved. An equation involving trigonometric ratios of an angle is called a trigonometric identity. For any value of theta, it would remain the same. So as I told you, the first and the foremost one is, and very important one is, cos square A plus sine square A is 1. Wherein for all values of A put in here or here between 0 to 90 degrees will all give you the value of 1. You can always check it out yourself, like cos square 30 plus sine square 30 will give you 1. Cos square 45 plus sine square 45 is going to give you 1. So this is small proof that's given in your textbook. Now you need not just look into it, just go through it. That is enough. You need not prove it, prove the identity. These are all called standard identities. And actually we are going to use these in proving the other identities. So as you see, they have here is a right angle triangle ABC, right angled at B. By using Pythagoras theorem, we have AC square is equal to AB square plus BC square. AB square plus BC square is equal to AC square. So by dividing, first time they are dividing each of the terms by AC square, and they come down to AB upon AC whole square plus BC upon AC whole square, and that is equal to AC upon AC whole square. That's nothing but equal to cos square A plus sin square A is 1. Same thing, that is 1, the equation number 1, when we are dividing by AB square. What are we getting? AB upon AB whole square plus BC upon AB whole square, and that's equal to AC upon AB whole square. So this is again, when we come down to it, we get it as 1 plus tan square A is nothing but secant square A. Moving ahead with the same, the first equation, this time we are dividing all the terms by BC square. So we are getting AB upon BC whole square, BC upon BC whole square, AC upon BC whole square. That is nothing but equal to cot square A plus 1 equal to cosecant square A. So all, as you can see, all the three identities we have proved. But you actually don't need to prove these things. You don't have to prove them. Just go through it. That's enough for us. We will be using these identities now further. Now I would like to share some screen, some PPTs with you. So please look up here.
It's Professor Dave. Let's verify trig identities.
He knows a lot about all kinds of...
I hope we are all ready with paper, notebook, pencil, and a pen, because whatever is done, it needs to be written down. And we will be solving few examples here. I hope everybody is writing these things down. So here I go.
Stuff Professor Dave explains.
We know a lot about trig functions now, including a number of identities they are involved in. This brings us to an area in trigonometry that can initially be quite infuriating, but it becomes incredibly satisfying once you get good at it, and that's verifying trig identities. The way this works is that we can have an equation with a bunch of trig functions on both sides. Sometimes this can be very messy, but we just simplify terms by applying certain identities to the equation say the same thing. Once we have done this, we have verified the identity. Let's start with a simple one, and you'll see what I mean. What if we have cosecant x times tangent x equals secant x? What can we do to prove that this is true? All we have to do is start rewriting things in ways that we know are true. For example, cosecant x is 1.
Now I would like to pause here for some time. Just look up, children. This is cosecant x multiplied by tan x is equal to secant x. This they are asking us to verify. So we are not going to start working out things like this. What we will do is, we will write LHS here and start solving the left hand side first. So I'm just moving back a bit. So we will be starting with the LHS. Please write LHS there and start working out on cosecant x multiplied by tan x. So the first thing is cosecant x is nothing but sin x. So put it down as sin x. Put tan x in the form of sin x upon cos x. Please do not write this part along with the LHS. This is your RHS, and this will only come down in the last stage. So what happens is, we are left out with the LHS as 1 upon cos x, and already your RHS was secant x, which is nothing but 1 upon cos x. So we have proved both the sides. I hope everybody is writing down all the examples that we are doing, because before moving on to the exercise, the textbook exercise, we have to go ahead with all these simple examples. So moving ahead. Now, what is it that we have? We have to prove that sin x multiplied by tan x is equal to cos x. Plus cos x is equal to secant of x. So as I said, always write LHS and let's start working on this. So sin x remains sin x, tan x converted to sin x upon cos x. Do not write the RHS along with the sum. When we are solving LHS, let's solve LHS first, then we will move ahead.
Here's the clever part, the part that can be frustrating when you can't figure out what to do. If we multiply this cosine x by cosine over cosine, it becomes cosine squared over cosine. That may seem arbitrary, but we do this so that we can combine the fractions, giving us sine squared plus cosine squared over cosine. The reason this is useful is that we can now use another identity we know, the one that says sine squared plus cosine squared equals 1. That means we can change them, and we have 1 over cosine. Done and done. So we have already outlined a few strategies that we can try.
Could everybody write down?
Yes, ma'am.
Perfect. Shall I progress now? Move ahead to the next.
It says sine squared plus cosine squared equals 1. That means we can change this to 1, and we have 1 over cosine. Done and done.
Fine. Finally, write LHS.
So we have already
to
outlined
RHS.
a few strategies that we can try. One is to rewrite individual identities. Another is to use this identity, which can allow us to change sine squared plus cosine squared into 1. Or it can allow us to change 1 minus sine squared into cosine squared, or 1 minus cosine squared into sine squared. Keep those in mind, as they will come in handy. And we've also seen that we can combine two fractions into 1. Naturally, we could also take one fraction and split it into 2 if there is a sum or difference in the numerator. Basically, you just start doing things that make sense algebraically, even if you don't know why you're doing them. And more often than not, the solution will eventually present itself.
The basic thing is, what they mean to say is, whenever you are in a proving sum, don't stop at any stage. Try solving the complicated part the first. If you feel the LHS is complicated than the RHS, then start with the LHS. If you feel the RHS is complicated, start with the RHS. But then finally see that one side is equal to the other side. So that's they're calling it as intuition. Basically, you should not stop. So keep on moving. Keep on writing whatever the logic says. As I always tell you, give importance to the logic.
Let's try some more examples. How about 1 plus tangent squared equals secant squared?
I would want you all to move ahead with this. I'll give you 1 minute of time. Let me see if you can do it. Check yourself also. Okay. I move ahead with this.
First things first, let's change tangent squared into sine squared over cosine squared. And
please do not touch upon the RHS. Please do not. Start with LHS. Move ahead with tan square x as sine square x upon cos square x. Leave the RHS as it is. We'll come back to it.
Secant squared into 1 over cosine squared. Here's a hint. We have just one term on the right, but 2 on the left. So what if we try to combine these two terms somehow? Well, to combine terms, you need a common denominator. So
what will be the common denominator? 1 plus sine square x upon cos square x. I think everybody knows that it's nothing but cos square x only. So now use your fraction logic and solve this.
express 1 as cosine squared over cosine squared. Now we can add them together, and we get sine squared plus cosine squared over cosine squared. Well, let's recall that sine squared plus cosine squared equals 1.
That is called the Pythagorean identity. And so we could prove.
So there we have it. This relationship is actually a basic identity we can use for other problems.
Amongst the 3 identities that I stated at the beginning, this was one of them. Then 1 plus cot square x is equal to cosecant square x is the other identity.
Along with 1 plus cotangent squared equals cosecant squared. Now let's try a couple that are harder than these. This one has 2 fractions on the left, 1 plus sine over cosine, plus cosine over 1 plus sine, and that will equal 2 secant x. Here's one where there's a few different ways to go. One strategy that...
Now here I would again like to pause. I would like you to look into it and understand and do. As already said, I also say there are hundreds of ways of doing math, but logic should be strong and move ahead. Answer is fine. You will get it. So I want everybody to work on this, please. I hope all are doing. Okay, moving ahead with this.
May jump out would be to combine these fractions by getting a common denominator. That is a totally valid way to go, but I can think of a way that's a little quicker. Take this second fraction. Whenever we have sums or differences in denominators, it's sometimes a good idea to try to get rid of those. If we remember how we used complex conjugates in manipulating complex numbers, we will know that the best thing to do here will be to multiply this fraction by 1 minus sine over 1 minus sine.
Here what are they doing is actually they are rationalizing. This is also called the rationalizing of denominators. Look into this, but there is another simpler method of doing the sum which I'm going to tell you about after this is done.
On the bottom, we FOIL that out and we get 1 minus sine plus sine minus sine squared. The sine terms cancel, leaving us with 1 minus sine squared, which equals cosine squared. Now we can cancel the cosine on the top and 1 on the bottom. And we have 2 fractions with cosine in the denominator. This means we can add them together and we get 2 over cosine, since the signs cancel. On the right, 2 secant is the same as 2 over cosine, and that's all there is to it. How about one more, since these are just so fun?
Okay, we'll stop at the moment because I need to show you how we can do. Okay. And I hope all of you can see this. The same sum, can you see I've done in this method? Written LHS is equal to, now taking the LCM as cos x multiplied by 1 plus sin x. So what do we get in the numerator? 1 plus sin x whole square plus cos x square x. So now when you have that 1 plus sin x whole square is nothing but a plus b whole square. So that's what? Hello?
Excuse me, ma'am.
Hello, yeah. Can you see?
A bit on top.
Yeah.
Yes. Next.
Fine. So 1 plus sin x whole square, I have written it as a plus b whole square. So that's sin square x plus cos square x, which is known as the Pythagorean identity. So you can add it up, right? So you get 1 plus 2 sin x whole divided by cos x into 1 plus sin x. So moving ahead, you have nothing but 2 plus 2 sin x divided by cos x into 1 plus sin x. Taking 2 common. Can you see that, children? Please write it down, Aniket. Everything needs to be written down. Okay. So 2 multiplied by 1 plus sin x divided by cos x, then again 1 plus sin x. Both of those terms get cancelled off. So we are left with 2 upon cos x, which is nothing but 2 of secant x. Done with it? Okay, fine. So there are various methods actually. You can adopt any. There are various methods. So I'll just move ahead with the same presentation again, where I stopped. So just moving ahead with it. Yeah. So here it is. This is sin square x plus cos square x is equal to cot square x whole divided by 1 plus tan square x. So we have to prove that the whole of the LHS is equal to cot square. So here we go.
Sine squared plus cosine squared plus cotangent squared all over 1 plus tangent squared equals cotangent squared. Now, there are a lot of ways we could go, and even if you pick a way that isn't the shortest way, you can still get to the answer. Like if we were to divide this into 3 fractions. It'll add some steps, but it's a totally legitimate way to go. There is one way that's probably the easiest, and I'll give you a hint. It will require all 3 of these identities involving squared trig functions. I'm sure you've already spotted a few things we can do. First, let's take sine squared plus cosine squared up here and make that 1. Now we have 1 plus cotangent squared, which is equal to cosecant squared.
So here we have used the identity again. 1 plus cot square x is equal to cosec square x. Then again 1 plus tan square x is how much? Secant square x. Fine. It's all given at the bottom. Can you all see that? So here we move ahead with this.
Then we can turn the denominator into secant squared. Just like that, we are almost done. Now we can rewrite cosecant squared as 1 over sine squared and secant squared as 1 over cosine squared. We know that dividing by a fraction is the same as multiplying by its reciprocal, so we bring
Bottom right corner unmute. Bottom left corner.
Ma'am, we can't hear you.
Okay, you all see the steps. We will send her a message to unmute. Okay, but you can still see the steps and see how it is going, right?
This is like going really fast. This is like the question part.
Tangent x. And let's see, cosine x times cosecant is 1 over sine x. So I can use that reciprocal identity. Then I'll have cosine x here times, I'm going to change this to sines and cosines. See, my ratio identity, then tangent x is sine x over cosine x.
Okay, is everybody on track? Any problems in understanding?
I'm keeping an eye on this side. I want to change this side into this side. So
Fine with that? This was very clear to all of you. So let's progress again. Move ahead.
I think Aniket just raised his hand. He has some problem.
cosine x times 1 over sine
Aniket,
x
you have to
is
use the raise hand feature of the
plus
Zoom.
here, cosine x times sine over cosine. I'll divide out that common factor of cosine and have left sine x. And so I see I've succeeded in getting what I want here. Cosine x over sine x using my ratio identity. That's cotangent x plus sine x.
So that is my RHS.
Changing the left side of this expression of this identity into the right side. So I've essentially proved this identity. So you can see by watching what I've done right here that you need to know those basic identities, reciprocal identities, ratio identities, Pythagorean identities to be able to do these problems. Here's another one. I have cosine to the fourth t minus sine to the fourth t over sine squared t is equal to cotangent squared t minus 1. So I'm going to start with this side here.
Now, what do you think we should be doing now? This cos 4t minus sine 4t, it can be clearly written as cos square t whole square minus sine square t whole square. So which identity do you think we will move ahead with, children? Nothing but a square minus b square, which is a plus b multiplied by a minus b.
I'm going to start by factoring